Hello Rhino community. If you're like me, you probably missed T-Splines for subdivision modeling right inside Rhino, and you might wish to continue to develop your T-Splines models in Rhino with a subdivision workflow. Well, as you probably already know, the Rhino 7 whip contains subdivision modeling tools that, even though they are a work in progress, already outshine any third-party plugin on the market. This tutorial will explore how to reverse engineer polysurfaces created from T-Splines objects into native Rhino SubD objects. Let's discuss 3 methods that we can use to achieve this. On the screen, I have an object that I made during grad school with T-Splines when we were exploring complex, smooth forms. Because I and many others no longer have access to the T-Splines for Rhino plugin, I'm left with this polysurface that would be impossible to continue to develop in its current state. However, we can use this polysurface as a base to generate a new SubD object that will function similarly to the original T-Splines model. First, let's try the toSubD command, which will convert any NURB surface into a SubD object. I'm going to go ahead and switch to shaded mode and type toSubD, select all my surfaces, accept all of the default options, and then I'm going to go ahead and move my polysurface off to the side. Now, looking at the SubD, it did create a similar object to the polysurface, but if we zoom in, we can see that it did not join correctly in some places, and it is still very complex. We would not be able to continue to manipulate this like the original T-Splines object. This may work in some simple cases, but is not a good option for this situation. The next method I want to show uses the new quad remesh command. It uses a unique algorithm to quadrangulate surfaces, polysurfaces, and meshes with an optimized polygon count. So I'm going to select my polysurface, and type quad remesh. First thing I'm going to adjust is the target quad count. For this model, let's pick a number around 100. Then I'm going to check the convert to SubD box with the interpolate SubD sub option. This option will help make sure that our resulting SubD is the same size as our original polysurface. Alright, I'm going to once again move my polysurface off to the side. The quad remesh command created a SubD that looks very similar to our polysurface, but its geometry is not reflective of the way that the model was modeled in T-Splines. We have a bunch of faces that are clustered at this tip, which I know is not how the T-Splines model was modeled. So this is better than our toSubD model. It does not give us the amount of control that we want to be able to manipulate this object in the way that it was originally created. This last method I'm going to show is a bit more tedious, but gives you the most control and ability to recreate the original subdivision layout face by face. But before we apply this method to our complex form, let's look at it on a primitive object first. So I'm going to isolate this. We want to create a SubD face for each surface that's inside this polysurface. And the first thing we need to do is run the dupe edge command and select everything. This gave us the edges of the surface, and I'm just going to go ahead and hide the polysurface. The next command I'm going to run is the intersect command, which, when ran, will give us points where each of our curves connect. We'll use these as points to draw our SubD faces. So I'm going to go up here to the single SubD face, and I'm going to change the polygon type from n-gon to quad. Just makes it a little bit easier to let it know when we're done drawing each face. I'm going to do 1 face, 2 face, 3 face, 4 face, 5 face. Now, I'm going to take all these SubD faces and join them together into one SubD, which is with the regular join command. Oops, I had crease on. I want to have crease set to smooth. And this gives us a SubD that looks similar to our original object, but it's much smaller. This is because the control polygon, if I toggle out of smooth mode, lines up to our polysurface faces. We want our mesh or our SubD vertices to line up there. So what we can do is we can toggle into smooth mode, and we can go to sub-object selection, select vertices, and we can just move these vertices over to the points that we used to create the faces, like so. And something to note is that when you move a point, the vertices adjacent to it are also going to move, because Rhino SubD objects maintain third-degree curvature, which helps keep everything nice and smooth. So there's a little bit of an art to this. I'm going to go into wireframe mode, and every time I move these points, it gets closer and closer to the original object. Okay, so let's take a look. I'm going to go back into shaded mode, and I'm going to toggle out of sub-object selection and move one over. And I'm going to show our original object. And now if we look, this is our polysurface, and this is our SubD object, and they are pretty similar. Now let's go ahead and apply this methodology to our complex object. I'm going to show selected, select our polysurface, and isolate it. And for this next step, I'm going to go into options and turn off ISO curves for shaded view under display mode settings. And I know two things about my original T-Splines model that'll help us for this step. I know that all of my faces were quads, meaning that they each had 4 sides. And the other thing I know is that for whatever reason, T-Splines, when converting objects to NURBs, would combine multiple faces into one surface. So this looks like it was one T-Splines face. And this here, this looks like it was one T-Splines face. But if we look at the one in between, this looks like it was 2 T-Splines faces, and it should have been split here if it were to represent each original face. So if we go to options and turn ISO curves back on, it looks like there's an ISO curve that runs right along that line. It'll be easy for us to split it into 2. So I'm going to take this polysurface and explode, and I'm going to split this face using the ISO curve option and toggle to go in the other direction. And I'm going to snap right to that edge and press enter. And that was able to nicely cut this surface into 2 pieces in a way that will represent each of the original faces. Now let's go around to the back of this model and look at this large surface. Now, because I know my original faces were quads, I know this needs to be split into several pieces, because this would have 1, 2, 3, 4, 5, like over 8 sides if this was one face. So this tells me it needs to be split into several pieces. I'm going to go into split, ISO curve sub option, I'm going to snap to that edge, toggle for the other direction, snap to this edge, and this edge, then press enter. Now that this is split into several pieces, it's starting to represent more closely to the original faces that made up the T-Splines subdivision model. Now let's orbit to the bottom of this model and take a look at a special condition. If you look at this edge right here, you can see it represents a crease that was applied to the original T-spline model to achieve a hard edge in this location. And if we select it, we can see that the faces that represented the bottom and on the side here were combined into one NURBS surface by the T-Splines algorithm. And in this scenario, we can use the divide along crease command to help break this into pieces that represent its original geometry. Looks like the output was a poly surface, so I'm going to go ahead and explode that. And it did. It broke it into a few pieces that seem to better represent the faces. Now, I'm going to go ahead and finish cutting this model into pieces that represent the original T-spline model faces. Alright, each of our surfaces has been cut into pieces that represent our original T-spline faces. Now we can go ahead and apply our methodology of drawing a SubD face for each surface. I'm going to go ahead and join these back together for a second, and I'm going to run the dupe edge command. Dupe edge, put those on their own layer. I'm going to hide our poly surface for now. Select all our curves and run the intersection command to get the points where the lines touch. Put those points on their own layer as well. And now I can go to draw a single SubD face, and I can draw a single subdivision face for each of these regions. Now that each of our SubD faces are drawn and joined together, I'm going to toggle into smooth mode, and we can see that we have a SubD object that is a little bit smaller than our original object. So the final step is to go into sub-object selection mode, vertices, and take each of the vertices and move them up to the location of their control polygon point. Alright, I just spent several minutes aligning our SubD vertices to the location of our original T-spline vertices. And let's compare it to the original. I'm going to move my SubD off to the side, turn off these points and curves, and grab our poly surface that I have hidden. And let's check them out in Arctic mode. Wow, they are really similar. I can't tell any difference between the two, and it's good enough for my purposes. Now, our new Rhino SubD model has the same subdivision structure as the original T-Splines model, and it can continue to be modified and developed with native Rhino tools. Alright, that's it for this tutorial. I hope you found it helpful. Have fun making great work with Rhino SubD.